Okay, let's try the false position method. For the false position method, I will use I will base my script on the script for the bisection method, which I did in the previous session. So therefore, I have opened that bisect lab, that script, and then I can save as another name. So in fact, bisect lab, I can say that it is FP lab, false position lab, FP lab. Okay. So now I can make some changes into that script. So what changes I can make? Okay, so suppose I am using the same function. So counter will start from 1 as before. Stopping error we can keep it as before. Okay, like 0.1, or in this case XL is -1, XU is 0. Okay, and then of course here there will be a change. Okay, because that is the that was the algorithm for the bisection method, because now the XR, that root will be calculated by the different formula, so I will delete it. So I first calculate the function, define the function. Okay, so function I defined by the format of anonymous function at x, and then minus 12 minus 21 x plus 18 x square minus 2.75 x cubed. So then the same function as before. Okay, so now I am also making a change with respect to the as compared with the bisection method. In fact, you can also do it in the bisection method, and in this way you can save a few lines in your script. So what changes I'm mentioning is that you can delete this. We don't have to define the variables for each of fxl, fxu, fxr, because we can simply calculate fxl by this notation, f of xl, f inside of xl. So I'm using this type. I'm using this type in this script for false position. Okay, so how? Okay, so let me see. So now I will use the formula for the XR, the estimated root. So estimated. So the formula for the estimated root is XU minus the value of the function at XU. So value of the function at XU. So here you can see that instead of defining if variable for f of xu, I can simply put f of xu, and then it will evaluate the value at xu. Okay, and then multiplied by according to the this is the false position formula. So it is xl minus xu, and then divided by f of xl. Now I'm using this format. Okay, instead of for f of xl is input in defining a separate variable, I can just use this notation, f of xl minus f of xu, and then I enclose it. But here I think there is one difference, because in this false position method we will calculate the relative error based on the first two estimated values. So therefore, before going into the loop, I should calculate at least two values of XR. Okay, so therefore it is better, I think it is more convenient for me to say this first estimated of XR, to say it as XR1. Okay, XR1. Okay, and then I will repeat the process, and then I will calculate the value of again XR2, and then from the value of XR2 and XR1 I will calculate the relative error. Okay, so after calculating the R1, then now I have everything to print. Okay, so I can first print the heading of the table, f print f. Okay, I can first print the heading of the table, such as like this. Okay, so it is as from the previous the same style as previously I adopted it. Okay, so this is the f printf. So what heading I will print iteration xl, and then with just put some arbitrarily some gap which you can adjust later on, xl, xu, xr, fxl, fxu, fxr, and then estimated error, and then n. And the arrangement you can change by your own liking. So for example, after xl you can put even fxl. Okay, and then xu, and then you can put fxu, value of xu, like that. Okay, so it is up to you what type of arrangement you want. And next I want to define a matrix Z which will hold the values of the values which I want to print. Okay, so this Z will be this. Okay, so this Z will be this. So Z, so first I will print I, which represent the iteration. So I have already initiated from 1, and then I will print xl, then xu, and then xr1. Yeah, xr1, which will represent the general heading for this is xr, and then fxl, then fxu, and then fxr1. So this one, and then next I will print the values using this z vector, which encloses which contains all the values. So control V. So this command fprintf will print these values. So as so this fprintf should be according to this z vector. So this z vector which is at the end, and then %5d and %f are the formatting. So f for the floating point numbers and d is for the integer. So I is the integer 1 2 3 4. So there are how many values over here? 1 2 3 4 5 6 7. Okay, and then remember that I did not put EA over here because for the first iteration there is no relative error. So that we can include later on in some other variation of the Z. Okay, so here we have 1 2 3 4 5 6 7, and then 1 2 3 4 5 6 7, and then slash n, and it shows that shows the next line. Okay, next this was the first set of values that will be printed. For the second set of values I need to give an increment to I is equal to 1. I is equal to I plus 1. Okay, so now the new value of the I will be needed. And then remember that in the script you must it is better to end each line with this semicolon. Otherwise in the result there will be so many unnecessary printout which we don't want. We only want to print things which we want to print, not everything. Okay, so after this then we will calculate. Okay, we will put the if statement. Why? Because in this case now because we have already calculated xr. Okay, and then corresponding to fxr we can calculate fxr. Okay, so now if fxl times fxl times f xr 1 in this case, okay, xr1, because the value which we have calculated xr1 is less than 0, then it will be the same same as we have used over here. xl will be xl. Okay, so you can use it like this over here. Yeah, so and then xl is equal to xl, xu is equal to xr. Because this is the bracketing method, so the same logic will apply here as it was for the bisection method. Then else if the same thing, fxl now instead of less than, it's greater than, is greater than, okay, sorry, greater than 0, then I will apply this here. xl is equal to xr 1. So okay, so here I think xl will be equal to yeah, here. Okay, we need to see it again. Okay, we have to be very careful over here. So if f of xl is into f of xr1 is less than or equal to 0, then xl is equal to xl, correct, and xu is equal to xr1, not xr. Okay, and if x1 ll into fxl r1 is greater than 0, then this is also else if, then xl is equal to xr1. Okay, and then xu is equal to xu, and else we can say that xr2 is equal to xr1, because now from xr1 we have to get the xr2 root. Okay, so that's why I have used now xr2 over here. Okay, and now I will end the if structure. So after end, then I need to calculate the xr2. So based on any of these three conditions, this condition, and then this condition. So xr2 will be then calculated by the similar formula as before for the false position method. So for example, here xr1 is equal to this, and now we will calculate xr2 is equal to xu, fxu, fxl minus fxl, and then same. Remember that these xl and xu values will be the one which will be updated within this if structure. So these will not be the one which will be in the previous case. Okay, these will be the updated value. So therefore we will get a an updated value of xr2. Okay, and now after xr2 has been calculated, now I can calculate the relative error, percentage relative error by this formula, because this formula, the previous formula which was for the bisection method, will not apply. Okay, so this is the relative error. Okay, in this case, so this will be based on the current value minus the previous value divided by the current value xr2 multiplied by 100. And then after that we want to print this value. So for this we need to use another z vector. So I will. Okay, so we will first of all then define the z vector. In fact, there is no need to say it as z1 vector. So because previous z vector we have already used, so we can just replace these values. So for this, the things which we want to print are this, same as before, but in this case we will add a EA, because now we can calculate EA. So the only difference between this Z and previous Z is that in the previous Z we did not include EA because we cannot calculate EA over here, but now we are including EA. And this command is not needed because this is only used for the heading. We have already provided it, and then we can provide this command like accordingly how many values of z are here. That means f printf. So this will be like that. So for example, yeah, if this is representing z, so this is represented by z, then 1 2 3 4 5 6 7 8, and then 1 2 3 4 5 6 7 8. Okay, and then backslash n for the new line. Okay, so now we have the EA, and then we can compare it with ES. So while EA is greater than ES, so we can now continue this loop. So here we have to make some amendments in this if structure, if xl, if f of xl. So now I think because fxl is not a variable, I'm just using its function equivalent. Fxl is times fxr 2, because the latest fxr now is fxr2. Okay, xr2. Okay, that will be used is less than 0. Then xl will be equal to xl will be equal to xl, or xu is equal to xr2 in this case. Else if f of xl into f of xr2, okay, is greater than 0, xr2 is greater than 0, then xl is equal to xr2, and now xu is equal to xu, else now xr3 is equal to xr2, because now from xr2 we have to go to xr2. Okay, so therefore we'll use xr2. So this will end the while if statement over here. After we end the if statement, then what we can do, we can increment I to the I is equal to 1, I plus 1, because these are the values which we want to print for the third iteration. So previously 2 iterations we have printed out, so therefore the value should be printed for the third iteration. Okay, and now we need to provide the value of xr3. Okay, because xr3 from the first 2 sections will be calculated by the similar formula as before. Just the thing is that xr2 will be replaced by this, and these were the things which were from the previous script, so we can delete it, and similarly this we can delete it. Okay, so here we can see that xr2 is equal to XU. So now we will need to calculate XR3. XR3 is equal to same, formula will remain the same, okay? This is the general form, and then this will, the values which will be used for XU, XL will be the updated values, okay? Now we go to the this next line. Yeah, next line. And this next line, what we will put, we will calculate the EA. So EA we will now calculate from the, as we calculated before. So this EA will be calculated as we calculated before, but in this case the comparison is between XR3 and XR2. Earlier it was the comparison between XR2 and XR1, but now the comparison is between XR3 and XR2, and then it should be divided by XR3. Okay, so XR3 minus XR2 divided by XR3, okay, times 100. And now we can we need to just provide the values of Z. The values of Z will remain the same as before. The values of Z will remain the same as before. So for example, here now we need to put XI, XL, XU, XR, and then we need to provide FXL, FX U, and F. These values should come. Maybe we maybe you can calculate. These were the values which were from the previous one, so maybe confusing. So let me get these values from the previous statement. So this was the value of the Z, which was used for the second iteration. So XL, XU, XR2, FXL, FXU, and then it should be FXR2. Yeah, there was a mistake over here. It should be FXR2, and then EA, which is the based on the XR2 minus XR1 over XR2. Okay, and now I can just copy these values over here for Z. So now Z is I, XL, XU, XR 3 in this case, right? XR3, need the values of XR3, and XL, XU, and then FXR3 over here. XL, XU, XR3, FXL, FXU, FX3, and EA. Okay, and now how many values are here? 1, 2, 3, 4, 5, 6, 7, 8, and then this is the value of Z over here. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, and then 1, 2, 3, 4, 5, 6, 7, and then I think one more value should be put over here. Control C, and then Control V. Okay, one more. So now it's correct. So, but before we end, then what we can do is we can replace this XR2 variable with XR3 variable. Why? Because when after this the loop will be repeated, and for that repeated loop we need to use the XR2 values, but XR2 values should be now updated. So we have updated the value of XR2 with XR3, and then in this case this loop will be repeated until the value of EA will be less than ES. So this hopefully completes the script, and maybe now maybe I can run that script. Okay, so save the script. So if you click anywhere else on the screen outside of the edit, then it will be saved. So FPLab has been saved, and then I try to run it, and in fact unfortunately I have found some error in the line 8 column 34. So line 8 I have found some got some error. Okay, and invalid expression when calling a function or indexing a variable, use parentheses, otherwise check for the mismatched delimiters. Okay, I need to check the error. Okay, so in fact the error is that I forgot to place one closing bracket for the denominator here. So hopefully this will correct. So now I save it and then I run it. So it looks like the function has run correctly. Yeah, so we have obtained these values for this false position method. So you can see that at the end, after the 7th iteration, the estimated error is less than 0.1. Okay, estimated relative error is less than 0.1, and the root is minus 0.41464, and the value of the function at this point is almost very close to 0. And you can see that in this case the columns have been also formatted and aligned very well. So this was how we developed the script for the false position method. So as before, so we can use the same script for some other functions and other stopping error and the other XL and X0 values.